Sathyabama Institute of Science and Technology.
Good morning all. Myself Dr. Nancy Noella, Assistant Professor, Department of Computer Science and Engineering, Sathyabama Institute of Science and Technology. In this video, we are going to see about agglomerative clustering with the single linkage method. Agglomerative clustering, we can name it as bottom-up clustering. So here, we are selecting each individual clusters from the whole data set. So for example, when we are having a data set, we will be having number of data items. So in this agglomerative clustering method, what we are doing, we are finding the most tight similarity between the data items in the data set, and that will be cluster first. Then we will find out which is the data item which is having the more similarity, then it will be merged with the previously find out one. Likewise, it will be going as a descending order of similarities or ascending order of dissimilarities, we can tell. So agglomerative clustering, here we are considering each data items or data point as individual clustering. So initially each will be different individual clustering. From that, one by one we will be merging according to the similarity of the data items in the data set. So the process will be repeated again and again until all the data points comes under one cluster. So to make this process very easier, we are making another one tree-based representation. It is known as dendrogram. Okay, so this is a tree-like structure which is named as dendrogram. So this is an example for dendrogram. So here A, B, C, D, E, F. These are the data items, and using this dendrogram we can find out what is the first created cluster, what is the second created cluster, and what is the last created cluster. So once all the clusters comes under a same group, we can wind up or stop the process. So linkage criterion, we are having the same method what we are using for other clusters. Distance is the factor. So using distance, we are having different type of clustering methods under agglomerative clustering. Single linkage, complete linkage, and average linkage are the most commonly used agglomerative clustering methods. So in this particular video, we are going to solve a problem using single linkage. So single linkage, we can call it as nearest neighbor. It will be taking the minimum distance or we can call it as loose clusters. So minimum distance we will be considering when we pair the data items, and in complete linkage we will be using the maximum value, and in average linkage we will be using the mean value. So I will explain all these concepts when we solve the problem. So this is the problem. Consider this is the data set, and in this data set we are having 6 data items, and the data items is having 2 variables x and y, the values of x and y which is given. So what is our task is to find out what are the data items is having more similarity between each other, and we have to make a dendrogram for this particular given data set. So first step, we have to plot each and every data points. So here we can see 1, 2, 3, 4, 5, 6. All the data items in the data set is plotted as a graph using its x and y value. So how we can find out? So here for P1 0.40 and 0.53 are the values. So how can we plot this as a graph? 0.40. So here x value is 0.40 and y value is 0.53. So likewise we can plot data items from data 1 to data 6. So next step, you have to find out the distance of each and every point. So here we are using the method Euclidean distance. Everyone know what is the formula to find out Euclidean distance. So x1, y1 and x2, y2 are the 2 different points of 2 different data items. Then we can calculate the distances root of x1 minus x to the whole square plus y1 minus y2 the whole square. So here 2 different data items are given. P1 and P2 is given. So here the distance of P1 and P2, how you can select, you know, for P1 0.40 and 0.53 are the points, and for P2 0.22 and 0.38 are the points. So how you can calculate the distance? Root of 0.40 minus 0.22 the whole square plus 0.53 minus 0.38 the whole square. So once you compute this one, you will be getting the value as 0.23. Step 3, we have to construct the distance matrix. So to construct the distance matrix, we have to find out the distance between each and every points. So consider P1 and P1. Obviously from one point to the same point the distance is 0. So we can find out P1 is 0 So that is directly we can write all the values of same points as 0. Now we have to compute the distance for P1 to P2, P1 to P3, P1 to P4, P1 to P5 and P1 to P6. So same wise the Euclidean distance formula have to apply for each and every points, and we can find out the values for all these values. So this problem is about single linkage problem. So keep that in mind. We are having different methods. If it is single linkage methods, you have to use the same method, whatever I am telling. So once you compute the distance metrics, you choose the minimum distance from this one. So minimum distance is nothing but you just compare each and every points in this matrix. Obviously 0.11 is the least distance. So you have to select that one. So here 0.11 is the least distance. Find out what are the points which is making that distance. So P3 and P6 which is making the distance. So P3 and P6, 3 and 6 which comes under the first cluster. Okay, so you can draw the dendrogram now with the least level 3 and 6 which is the first cluster formed. Now actually in the previous slide we understood P3 and P6 which is having the least distance, and hereafter those are not 2 points, you have to consider that as the same point. So how can you name P1, P2, P3, P6 same point, then P4, P5. So that is the updated distance matrix P1, P2, P3, P6 as the same point and P4, P5. So everything is same, but the green highlighted that columns you have to find out. That only is unknown. Remaining all things you can directly write from the previous matrix. This particular table you can fill up the other values. Only for the newly found group P3, P6 you have to find out the values. So here single linkage comes. So in single linkage, when you combine different points and when you are find out the new point, you have to find out the minimum distance. So here in single linkage, you have to use the minimum distance, and in complete linkage, you will be using the maximum distance, and in average linkage, you will be taking the average values between the points. So here how you can find out? So actually you have to find out P3, P6 with the P1. So how can you find out P3, P1 distance, P6, P1 distance? So it is there here. P1, P6 value is 0.23. Check it out, 0.22 or 0.23. Which is having the minimum distance? Obviously 0.22. So that value have to be written here. Next we have to find out the distance between P3, P6 with the P2. P3, P2 is 0.15 and P6, P2 is 0.25. Single linkage method, you have to use the minimum distance. So 0.15 or 0.25, which is the least distance? Obviously 0.15. So that value will be written here. Same thing you have to do for P3, P6 with the P4, P3, P6 with the P5. So once you complete this one, you will get the updated matrix which is given here. So this is completed, and this is a newly created distance matrix. Now using this one, you have to find out the next one. So among this one, so this is the newly created, right? Among this one, which is having the minimum distance, you can find out 0.14 is the minimum distance. So 0.14 is what? It's a combination of P2 and P5. So next cluster will be P2, P5. Can we check? Yes, 0.14 is the least distance, P2, P5, which makes that. So this will be the newly updated cluster P2, P5. So 2 and 5 will be the next cluster. So whatever you are updating in the distance matrix, you have to do in the dendrogram also. 2, 5. That is the new cluster. So secondly only we generated that particular cluster. So the level will be somewhat higher than that one. So this is the maximum similarity. Next maximum similarity, likewise it will be going on. The similarity will be going on as a descending wise. So here you have to find out the distance of P2, P5 with the other points. So P2, P5, hereafter it is 1 point. So P2, P5 with the P1, P2, P5 with the P3, P6 and P2, P5 with the P4. Okay, these comparison, once you are computing this one, for example, P2, P5 with the P1. So how you will be finding out P2, P5 with the P1, 0.23 and 0.34, which is having the least distance, 0.23. So that will be the value here. Now to update the distance of P2, P5 with the P3, P6. You know what is the distance between P2, P3 in the previous slide. So you can check that one, P2, P3, P2, P6 and P5, P3 and P5, P6. Compare the distance of each and every values and take which is having the least one. So once you compute this one, you will be getting 0.15 as the least distance. So that will be written over here. Same wise for P2, P5 with the P4. You will be getting the value of 0.20. So once you compute this one, so you will be getting here the minimum value is 0.15. Correct. So once you compute this one, this is the updated matrix, and from this one 0.15 we are getting the minimum distance. So 0.15 P2, P5, P3, P6 we are getting as a group. So hereafter P2, P5, P3, 6 are no two different clusters. You have to consider it as a single cluster. So you can merge those. So P2, P5, P3, P6 are the refined clusters. So already it is there. So you can join those two in the dendrogram. The same process you have to do for what? So P2, P5, P3, P6. So compare all those distance among this one. So P2, P5, P3, P6 with the P1. You have to find out which one is having the least distance is 0.22. The same thing P2, P5, P3, P6 with the P4 you have to find out. You will be getting 0.15 as the least distance. So all the calculations are given here. You can check into this. Okay. So from this one, which is having the least distance, obviously P2, P5, P3, P6 with the P4 is having the least distance, 0.15. So it will be the next cluster. How you got P2, P5, P3, P6 with the P4 is the next cluster. So you can make that one, it's a new cluster. So same dendrogram, 4 is having the least distance, it is joined. This is the dendrogram. And finally, only we are having one point that is exempt from this one. You can join all those things and you can draw one as the new cluster. So which is given over here. So each and every updated matrix which will be telling you the minimum distance. So in this particular single linkage problem, you have to consider only the minimum distance. Minimum distance you have to take an overall matrix as well as when you are merge some points, and when you are making the comparison also you have to take the minimum distance in single linkage. So finally we got the dendrogram. So what is the meaning of this dendrogram? 3 and 6 was the firstly created cluster. Then 2 and 5 joined with that. Then 4 was the cluster which joined with the previous one, and finally one cluster, the cluster 1 joined with that one. So this is the final cluster. So from this, earlier you had plotted all these things as a graph, right? So here you can plot 3 and 6, first 5, 2, second, then those together, then 4 joined with that one, then the last point, data point 1 joined with the whole cluster. So once the whole data points comes under a single cluster, you can stop this process. The same thing you can try with the complete linkage problem as well as average linkage problem. So we will be discussing in the upcoming videos. Thank you.